Section 4.6, we're going to talk about how we can find or approximate an integral, even though we don't necessarily know how to take the integral. Say we come up to some really hard function, and we just, for the life of us, cannot figure out how to take the integral of that. Well, we can approximate that integral by using what's called the trapezoidal rule. And if you remember how we were first learning how to take integrals, we were doing the limit of a summation of some graph, right? And we're breaking it up into a bunch of squares and all that stuff. Well, the trapezoidal rule, all right, well, we're breaking it up into a trapezoid, kind of. The first one's a little different there, but here to here, and it'd be like a trapezoid going like this and so forth, right? So instead, it's called the trapezoid rule because we're breaking it up into a bunch of little trapezoids, and our error is just our little distance in between that curve and the straight line that makes the top of the trapezoid. All right. So if we cannot figure out how to take the integral, we'll just go ahead and we'll approximate it using the trapezoidal rule. All right. And here's the trapezoidal rule. If we're given an integral from a to b, all right, what we do is they'll tell us how many, this n is how many trapezoids we're going to break our area into, all right? So we'll take our b minus a, so our upper limit minus our lower limit, all right? And then we'll start at the very end point of our trapezoids and continue and just plug it into the function, all right? Notice the pattern, the trapezoidal rule, will always have a coefficient of 1 at the beginning and 1 at the end. And it'll also, for the rest of them, be plus 2 times the function at that point that we're choosing. Okay? So to illustrate that, I'll do one right here. They want us to use a trapezoidal rule to approximate when n equals 4 and n equals 8 of sine of x dx from 0 to pi. All right? Well, to start out the trapezoid rule, we go, so we're working down here. All right, to start out the trapezoid rule, we're going to go our upper limit minus our lower limit, so pi minus 0 all over 2 times, well, n equals 4. We're breaking it up into 4 trapezoids. So if you think about our sine graph, something like this, sine graph, we're going from 0 to pi, and actually this is pi. All right, we're breaking it up into 4 trapezoids. So 1, 2, 3. So there should be 4 trapezoids in there, okay? So what this says now is we need to take pi minus 0 all over 2 times 4 times the function, so sine of x, or not sine, sorry, sine of our very beginning point, which is right here, 0. So sine is 0 plus sine of, well, if we broke this down, if we're breaking into 4 trapezoids, this has got to be pi over 4. This has to be pi over 2, and this has to be 3 pi over 4, right? We broke it down into fourths. So this will be sine, it'll be 2 times the sine of pi over 4 plus 2 times the sine of pi over 2 plus 2 times the sine of 3 pi over 4. And then plus, then remember how the pattern goes, just the sine of pi. All right. And obviously over here to the left, this just simplifies down. Instead of writing that, we can just write pi all over 8, right? Okay, and we can go ahead and we plug it into our calculator, and we'll figure out, when we do the trapezoidal rule there, we'll come up with 1.896. 1.896. This would be a good time to stop the video and make sure if you plug all that stuff in, you know you're plugging in right and you get 1.896. All right? And they want us to compare that with breaking it up into more trapezoids. So they want us n to equal 8. So we're going to have this time, instead of pi over 8 on our outside, it's going to be pi all over 2 times 8, which is 16, right? And we're breaking this, we're going from 0 to pi, and we're breaking it up into 8 segments now. Okay, so if you think about it, we're breaking each of those going to be pi over 8, then we're going to have pi over 4, 3 pi over 8, pi over 2, all that stuff. So we would want the sine of 0 again, plus the sine of pi over 4, or no, pi over 8, plus, 2 times the sine of pi over 8, plus 2 times the sine of pi over 4, plus 2 times the sine of pi over 2, all the way, all right, so you guys can continue doing that, all the way to finally, at the last part will be just the sine of pi, right? And the one before that would be 2 times the sine of 7 pi over 8. So you keep going up by pi over 8. All right, and when you figure that out, you type that all on your calculator, you're going to end up getting 1.974. 1.974. And what they're illustrating, what they're getting at is the more trapezoids we break it into, obviously the less error we're going to have, the closer our approximation is going to be. All right, just like with the more rectangles when we're learning to take integrals that we took, the closer the approximation was. Okay, so that's the trapezoidal rule. All right. Here they just include a shortcut if we want to take the integral of a trinomial. Notice we have a squared plus bx plus c. All right, if we want to take the integral of a trinomial, we're just going to go our upper limit minus our lower limit divided by 6. We'll plug our lower limit in, and then we'll add it to it. All right, 4 times the value of the upper and the lower limit divided by 2. So say this was from 0 to 4. Okay, so we'd say 0 plus 4 divided by 2 would be 2, right? So we'd plug 2 into our function there. All right, and then we'd also, there should be one last guy over here. We'd also then take it and add it to our value of our upper limit. Okay, so just a nice little shortcut. The proof is in the book if you want to look at the proof of that. But I'm not going to show you. We don't have time to show you here. Okay, so one more thing that could make it simpler, we can use Simpson's rule also to approximate an integral. All right, so if we're given n to be even, we can use Simpson's rule here. So if our n is even, so we're breaking up in an even number of them, all right, we just go our upper limit minus our lower limit divided by 3 times the amount of, so 3 times n, all right, and everything's the same yet. Notice now how this alternates. Okay, so there's a 1 at the beginning, then it goes 4, 2, 4, 2, 4, 2, 4, 2, all the way to your last term is just a 1 again. Okay, so if that pattern helps you remember the formula, also you'll be able to write these formulas down and use them. I'm not going to ask you to memorize these. Okay, so then if we were to use this, if we wanted to use Simpson's rule, so this is just like the one we did above. All right, so we're going to use Simpson's rule. We're going to go b minus a, so it'll be pi minus 0 is just pi, all over 4 times 3, which is 12, because that's what our formula says here. All right, times the sine of 0, because that's x0, plus 4 times the sine of, let's see, we're breaking into 4, so it'll be pi over 4, plus 2 times the sine of pi over 2, plus 4 times the sine of 3 pi over 4. And then our last term would be plus then the sine of pi. All right. And again, we go through and we type that into our calculator. And when we type that into the calculator, we get approximately 2.005. So about 2.005. So it's awfully close to what we did earlier. So just another way that we can use to approximate an integral. Okay. So that's it for this video. We'll see you in class.